Capstone project, build your first ML model in Python. Welcome! You are going to learn how to build a real machine learning project using Python. No coding background needed. We will guide you step by step with small, friendly examples. You will work with data, make predictions, and see how machine learning can solve real-world problems. Ready? Let us dive in. Running the cell now. Let us start by bringing in some helpful tools. We are turning off warning messages to keep things clear. Pandas and NumPy help work with data. This line is a comment. Comments explain code and start with a number sign. This line gets a tool that helps silence warning messages. This line will turn off Python warnings, so you see only important output. This gets a tool called Pandas for working with tables and spreadsheets. This pulls in NumPy, a tool for working with numbers. Running the cell now. Practice, try typing an import line for another tool, like Matplotlib. What is machine learning? Machine learning is a way for computers to learn from data, like people learn from experience. You give the computer data and some examples of the answers it should learn. Then, it can make predictions about new data. Today, we will use the Titanic dataset to predict who survived the famous shipwreck. Running the cell now. Now let us get our data. We download the Titanic data from a website with one line. We show how many rows and columns there are. Then we look at the first 5 rows. This line is a comment to explain the next steps. We set the web address for our Titanic data. We load the data from that web link into something called a data frame, which is like a spreadsheet. We print out how many rows and columns we have. We ask Pandas to show the first 5 rows of the data, so we can see what it looks like. Running the cell now. Look at the table. Can you spot that you survived and sex are columns? Let us quickly check how many people survived and how many did not. This line explains what is next. We count how many passengers survived and how many did not, using value_count on that survived a column. Running the cell now. Challenge, what do you think 0 and 1 mean in this column? Basic Python, variables. A variable is a name that stores a value. You can use variables to remember numbers, text, or anything else you want to reuse. Let us try making some variables. Running the cell now. Let us save your name and age in variables. We will print them out to see how it works. This is a comment to describe the code. We create a variable called my_age and give it the value 15. We create another variable called my_name and give it the word Sam. We tell Python to print out our name. We ask Python to print out our age. Running the cell now. Try changing the name and age to your own in the code above. Now, let us ask you for your favorite color. This will let you type your answer. Here is a comment to show what happens next. This line asks you to type your favorite color and stores it in favorite_color. This prints out a friendly message including your favorite color. Running the cell now. Practice, try other questions with input. Selecting data in Python. We often want to look at just part of our data. For example, we might want to see all the women on the Titanic. This is called filtering or selecting. Running the cell now. Let us pull out all female passengers from the table. We will count how many there are, and look at a few. Here we write a comment. We create a new table that only has rows where sex is female. We print how many women are in this new table. We look at the first 5 rows for a preview. Running the cell now. You try, change female to male and see what you get. Handling missing data. Real-world data is messy. Sometimes information is missing. We need to check for missing spots and fill or remove them. Let us see if our Titanic data has any missing pieces. Running the cell now. Let us look for missing data. This helps us find which columns need some fixing. This is a comment for missing value check. We count how many missing values are in each column of our data. Running the cell now. Practice, which column has the most missing values? Let us fix missing age values. We find the average age, then fill all the blanks with that number. This is a comment for what is about to happen. We find out the average number in the age column. We fill in empty age spots with this average right in the original table. Running the cell now. Why might it be better to use an average than just drop the rows? Let us clean up. We will remove some columns that will not help our prediction. Comment for this cleanup step. We delete the cabin, ticket, and name columns from our data. Running the cell now. Try, what happens if you drop Vimbart as well? Turning words into numbers. Machine learning models work best with numbers, not words. We have to turn columns like sex into numbers. This process is called encoding. Running the cell now. Let us turn the sex column into numbers. This makes it easier for our model to use. Here is a comment to show what comes next. We map the word female to 0 and male to 1 in the sex column. Running the cell now. Can you think of other columns that might need this step? Let us try a simple machine learning model using one column. We split the data into training and test parts so we can check our work. We use logistic regression, a method for making yes or no guesses. Now, we train the model to learn from the data. A comment marks the start of our model. We get tools for splitting data and for our model. We import logistic regression, which predicts yes or no answers. We pull out just the sex column to use as our feature, or X. We set our target, or Y, to survived. We split the data into 80% training and 20% test. The random state locks our split for repeatability. We make a model using logistic regression. We teach or fit our model with the training data. Running the cell now. Why do you think we only use the sex column at first? Let us see how well our model did. We use accuracy, which is the percent of correct predictions. A comment for the next step. We use the model to predict who survived, just on our test set. We check how many times our model got the answer right. We print the accuracy so we can see how well we did. Running the cell now. Practice, try printing y_pred and y_test together to compare. Improving the model. We can help the model by adding more columns. The more useful information we give it, the better it can learn. Let us try using age and class along with sex. Running the cell now. Let us see if using more data makes our model more accurate. We add age and P class, which means ticket class. We train and test like before and check our new accuracy. This comment says we are using more columns now. Now our X has sex, age, and P class. Our target Y is still survived. We split the data into training and testing again. We create the model just like before. We train the model with our new columns. We check the score on test data and save it as accuracy. We print the new accuracy for our model. Running the cell now. Did your accuracy improve? Try adding more columns on your own. Let us have some fun. You can now try making a prediction by entering your own details. Our model will guess if you would have survived the Titanic. The comment describes this interactive step. This asks you for sex as a number. This asks your age. This asks you for ticket class, 1, 2, or 3. We change your answers into numbers so the model understands. We put your answers in a list for the model to use. We let the model predict for your case. If the prediction is 1, we print survived. Otherwise, we print did not survive. Running the cell now. Try different inputs to see how your answer changes. If you are watching on YouTube, type your prediction result in the comments. Best practices, random states and reproducibility. A random state helps us get the same results every time we run. This is important for sharing your work with others. You will see random state used in train test split a lot. Running the cell now. Let us see what happens if we do not use random state. You may get different results every time. This comment asks what happens when you skip random state. We split the data again but without the random state. We check if the new training data is the same as before. Running the cell now. How many times in a row do you get true? Let us look at a common Python error. It is okay if things break sometimes. We can use try and except to catch some mistakes. This comment is about finding and fixing errors. Let us deliberately try something that causes an error. We begin a try block, a safe place to run code. We try to divide 10 by 0. This will fail. We catch a 0 division error, Python's way of saying no dividing by 0. We print a friendly message instead of crashing. Running the cell now. Try, what happens if you divide by a number other than 0? Extra tips. Use comments, the number sign, to explain your code. Use print statements to check your work. Practice makes perfect. Try changing numbers and running cells again. You are well on your way to becoming a data scientist. Running the cell now. Now it is your turn. Try predicting survival based only on age and ticket class. Check the accuracy and see what happens. This line gives you your first mini project. We use just age and P class for our features. Our target for prediction stays the same. We split into training and testing data again. We create a new logistic regression model. We train the model with the new features. We print out the accuracy. See how well you did. Running the cell now. Can you beat the earlier accuracy? Share your results with a friend or family member. Capstone project recap. Great job! You loaded real data, cleaned it, built and tested your own model. You saw how simple steps add up to real data science skills. With practice, you will improve and try bigger challenges. Keep experimenting and having fun with your new superpower. Running the cell now. Next steps and YouTube call to action. Thanks for following along. If you enjoyed this lesson, hit the like button and subscribe for more beginner Python and machine learning projects. Try changing the data or adding your own twist to the project. Happy coding! Running the cell now.